Without a doubt, the most common kind of factoring that you'll do while you're in high school math, at least, is factoring trinomials. And so we're going to spend the bulk of our time learning how to factor trinomials. And trinomials are, when they're written in standard form, written like this. They're written as ax squared plus bx plus c. I guess it'd be more accurate to say ax squared plus bx plus c. But we're going to start off by factoring trinomials where the a is 1, meaning that there is no leading coefficient in front of x squared besides 1. So there's going to be a coefficient in front of b. In this first example, x squared plus 7x plus 12. The b is 7. And then there's going to be a constant added on to the end, which in the first example is 12. And so when you have a trinomial that you're factoring, just like with every factoring problem, the first thing you look for is a greatest common factor. And then after you take care of the greatest common factor, if there is one, you're going to factor your trinomial into two sets of parentheses. So all of your answers are going to look like two sets of parentheses, maybe with a greatest common factor in front, maybe not, depending on if there is a greatest common factor. And to start off with, we're going to do real simple ones that don't have a greatest common factor. We're still going to check for them just so we get in the habit of checking for a greatest common factor. But there won't be greatest common factors for these first few that we're doing. And then all of our answers are going to be two parentheses. Okay, so when we look at this first problem, x squared plus 7x plus 12, we check for a greatest common factor, but x squared, 7x, and 12 don't have a greatest common factor, or rather they do, but it's 1, so it's not a useful greatest common factor. So then we go to our two parentheses. So we're going to have two parentheses for our answer. And when we multiply these two parentheses together, we should get x squared plus 7x plus 12. Now, if I gave you the two parentheses and we started multiplying together, the first thing that you would multiply is this term right here multiplied by this term right here. And that's where the x squared in our problem would come from. What this means is if our trinomial starts with x squared, we know that our two parentheses are both going to start with x. If your trinomial starts with x squared, your two parentheses are going to start with x. And so the only thing that we really have to figure out is what are these other two numbers going to be? What number's going to go here and what number's going to go here? So our trinomial has all plus signs. It's plus 7x plus 12, and that tells us that whatever numbers go here, they're both going to be positive. So what are those two positive numbers? And it turns out that in a trinomial, the numbers that go in these spots follow the same pattern every single time. Our two numbers have to do two things. When I multiply these two numbers together, so whatever these two numbers end up being, when I multiply them, the product equals C. And when I add them, the sum equals B. So in this problem, what I'm looking for is two numbers that when I multiply them together, I get 12. And when I add them together, I get 7. And there are only two numbers in the whole world that do that. That when you multiply them together, you get 12, and when you add them, you get 7. And you may already just instinctively know. You're like, that's easy. I know what those two numbers are. But we will eventually do some polynomials with very big numbers, and you won't just be able to look at it and go, I got this easy. So one thing that you might find helpful is to make a table of one column that has the product of two numbers and another column that has the sum of two numbers. And so for the product, I want to write down all of the combinations of numbers, whole numbers obviously, all the whole numbers that have a product of 12. And that would be like 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and that's it. There are no other pairs of numbers, whole numbers, that have a product of 12 unless I start doing negatives, like -1 times -12, -2 times -6. But I don't have to worry about negatives because I know both of my numbers are going to be positives because my original polynomial was all positives. Okay, so I know my two numbers are going to either be 1 and 12, 2 and 6, or 3 and 4. Now the question is, when I find the sum of those numbers, what's the sum going to be? So 1 plus 12 is 13, 2 plus 6 is 8, and 3 plus 4 is 7. So of the three combinations of numbers that have a product of 12, only one of those combinations also has a sum of 7, and that is 3 and 4. So my solution is x plus 3, x plus 4. And that's the factored version of x squared plus 7x plus 6. And I can check this and see if I've done this correctly by using the distributive property. So let's go ahead and check it real quick. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. And when I do 3x plus 4x in the middle, I get 7x. X squared plus 7x plus 12. So when I check my answer, I get x squared plus 7x plus 12. And maybe when you first heard me say two numbers that multiply to get 12 and add to get 7, you were like, it's 3 and 4. I know it's 3 and 4. You can go straight to the answer without making the table. And eventually, once you start factoring for a while, you'll be able to do these with a lot of factoring problems, especially if you're really good with your multiplication tables. You just be able to go straight to the answer. And that feels really good whenever you can go straight to the answer without making the table. But we will occasionally have really big numbers for our C value, or when you get negative numbers for C value, or sometimes negative numbers for B value, there are a lot of combinations. And then the table becomes really useful also. So let's do one more here. B is 3 and C is 2. There is no greatest common factor. So we start writing our parentheses, and our parentheses are both going to start with x because that's the only way you can get x squared. X times x is x squared. Because b and c are both positive, I know these are both going to be plus. And so what is the number that goes here? I need two numbers that I can multiply to get 2. So the product is c, which is 2. And the sum is 3. Well, this one's really easy because there's only one product of 2 with whole numbers, and that's 1 times 2. And lucky for us, 1 plus 2 is 3. So this is the answer. So that one's really easy because 2 is a prime number. There's only one possible combination of numbers, and it's 1 and 2. So that's how you factor a trinomial into two parentheses when both the b and c are positive. And this is the easiest one because we know both of our numbers in the parentheses with the x's are going to be positive. And in the next lesson, we'll look at what happens when they're not both positive. How do we figure out what those two numbers are going to be?